Okay, here we have the distance formula taken from the formula book. It's just an extension of the length of line formula when you've got two dimensions, which is it's just alongside Pythagoras. It can be quite easily proved, certainly, that d squared, as in the distance in a 3D space, equals x squared plus y squared plus z squared. It can be proved quite simply by just sort of drawing a picture of a cuboid and considering the bottom of it as the xy plane and the height as the z, and just working out the floor diagonal and going from there. It's not that much, and then the step up to this, it isn't that big. I'm not going to handle the proof today. I'm just going to show you how one way it can be applied. But this is taken straight from the formula book. The distance between 2 points. So if 2 points are defined as x1, y1, z1 for the first point and x2, y2, z2 for the second point, then d, as in the distance between those points, is the x1 minus x2 squared, as in the distance between the x's, squared, plus y1 minus y2 squared, same with y, plus z2 minus z2 squared. So you take all those distances in the x direction, y direction, and z direction, square them and add them and square root, and that will give you the straight line distance between 2 points in a three-dimensional space. So we're going to use this distance formula to show that 3 points F, which is at 1 minus 1, 3, G, which is at 2 minus 4, 5, and H at 5 minus 13, 11 are collinear. Now, if we just think about this, I can only draw in 2 dimensions. So if we just had 3 points, so let's say G, H, and F. So let's just say F. And we'll put one over here and one over here. So this can be F, G, and H. But don't worry about the actual bit. So, and if we just consider those distances separately, so this is FH here. And then if I just take a different color to draw FG, and another color to draw GH, if you think about it, well, FG, this purple distance here, FG, is always going to be longer than this dashed purple line I've drawn here, for the reason that if you just drop a perpendicular down, FG would be the hypotenuse of that little purple right-angled triangle. So if this point is anything above this red line, then you can see that that purple distance will always be longer than the dashed purple. We can use exactly the same reasoning for the green triangle. So if I drew this line as well, so that's just the projection line from the green line back to that red line, you can see that the solid green line will always be longer for exactly the same reason. It's the hypotenuse of that triangle. So the reason why we can use a distance formula to show they're collinear, well, collinear means they all lie on the same line, right? So if we just thought about moving that point, say G wasn't there, but it was actually on the line, which would mean the actual whole arrangement looked like this. We're just saying it's one line, so we've got F, G, and H, and H. If we were to do something like that, then you can see that FG plus GH is exactly the same distance as FH, and the only way that can possibly happen is if the 3 points are collinear. So if we can now use the distance formula, e.g. we're going to find out the lengths of the 3 lines. If any 2 of them, or if the 2 shorter ones add up to the length of the longer line, then they must be collinear, because the only way that can be possible is if they all lie in a line, for the reasons that this diagram shows. If they ever were not in a line, then the 2 shorter sides would be longer than the lines that would be formed if you projected them back onto the long line. Okay, so now that we've established that if the lengths of the sides of the 2 short lines, or the 2 short segments joining points, add up to the length of the longest segment joining points, then they are collinear. we're going to actually apply this distance formula to show that f, g, and h are collinear. So it's going to be a bit tedious. We're going to have to separately work out the lengths of fg, gh, and fh. So directly from the formula sheet, the distance between 2 points in a three-dimensional space is given by the formula shown. So the difference between the x-coordinates squared plus the difference between the y-coordinates squared plus the difference between the z-coordinates squared. Now, normally you would sort of pick one point as x1, y1, z1, another point as x2, y2, z2, and you would subtract like that. But given that we're going to square them anyway, it's often best just to do whichever avoids the most negatives. So I think that's what I'm going to do. So I'm going to say fg equals the square root of, so if we look at g and f, well, you've got 2 and 1 as the x-coordinates, so 2 minus 1 squared plus, and look at the y's, you've got minus 4 and minus 1, it's not going to make much difference, so minus 4 minus minus 1 squared plus, look at the z's, 5 and 3, so I'm definitely going to do 5 minus 3 squared. So that is going to be the square root of 2 minus 1 is 1, 1 squared is 1, plus minus 4 minus minus 1 is minus 3 squared is 9, plus 5 minus 3 is 2, 2 squared is 4. So 9 plus 4 is 13, plus the 1 is 14. So fg equals root 14. So we're going to have to do a bit of surd simplification for the other ones if this is going to work. So next I'm going to look at gh equals the square root of, so compare the x-coordinates, you've got a 5 and a 2, so 5 minus 2, we square it, plus, look at the y's, you've got a minus 13 and a minus 4, so I think I might call that minus 4 minus minus 13. And then we square it, and now we need to do the same with the z's. So that is 11 and 5, so 11 minus 5. And we square it. So 5 minus 2, we have the square root of 5 minus 2 is 3, 3 squared is 9, plus, and we have minus 4 minus minus 13, it's the same as minus 4 plus 13, which is the same as 13 minus 4, which is 9, 9 squared is 81. Plus, then we have 11 minus 5 is 6, 6 squared is 36. So now, I think I might pull a factor of 9 out of that early actually, so I might say that's the square root of 9 times 1 plus 9 plus 4, which is quite handy because 1 plus 9 plus 4 is our 14. So we've got root 9 times 14, or root 9 times root 14. So that is 3 root 14. And finally, we will look at fh. So f is at 1 minus 1, 3, and h is at 5 minus 13, 11. fh equals the square root of, so looking at the x's, you've got 5 minus 1 squared, plus, looking at the y's, you have a minus 13 and a minus 1, so we can call that minus 1 minus minus 13 squared, and then we add to that. For the z's, you've got a 3 and an 11, so we'll call that 11 minus 3 squared. Remember, we can interchange these because we're just looking at the distance between them and we're going to square it anyway. So that gives us the square root of 5 minus 1 is 4, 4 squared is 16, plus minus 1 minus 13, it's the same as minus 1 plus 13, which is the same as 13 minus 1, which is 12, 12 squared, 144, plus 11 minus 3 is 8, 8 squared is 64. Again, we look for common factors, and I think 4 looks good, but actually I think potentially will 16 go? 16 will definitely go into 16 and 64. Will it go into 144? So what you could do, if you want to divide by 16, you could think, well, 2 times 2 times 2 times 2 is 16. So if we take 144 and we divide it by 2 times 2 times 2 times 2, that should tell us what 144 divided by 16 is. So if we divide it by 2, 72, divided by 2 again, 36, divided by 2 again, 18, divided by 2 again, that is 9. So 16 nines are 144. So now we can say this is the square root of 16. 1 plus, we just said this was 9, plus 16 fours are 64. And again, we've got this 1 plus 9 plus 4, which is our 14. So in the same way as before, we've got root 16 times root 14. Square root of 16 is 4, so this is 4 root 14. So now we have our 3 distances, root 14, 3 root 14, and 4 root 14. So if you combine the first 2 root 14 plus 3 root 14, that gives us 4 root 14. So this does show that the points are collinear. So let's just write that down and make sure we know what was what. So the first one was FG, the second one was GH, and the third one was FH. So FG plus GH equals root 14 plus 3 root 14 equals 4 root 14, which does equal the distance FH. Therefore, or it follows that FG and H are collinear. Okay, so you could draw a straight line that goes through all 3 points.